So space is hard, everybody knows. But with hard problems, there are also great opportunities. So what are the hard problems that you would like to see our students here and entrepreneurs addressing that would enable democratization of space?
I think one of the big things is getting there, being able to travel these large distances. I mean, the reason why, one of the major reason, among, well, there's lots of reasons, but traveling from here to Mars takes so long. We need a faster way to get around the universe, and so some of the research that's being done in electric space propulsion or ion engines, or as we're getting closer and closer to being able to use those, I think that's going to be huge, because because it takes so long to get to a place like Mars, you have to deal with things that make it just so much more complicated. How you're going to keep the crew healthy during all that time, physically, and also protection from radiation while you're exposed as you're on your way there, and so on. And if we're able to, if we really want, so that's why Mars is kind of our limiting place right now to send people. To go beyond that is, we can't even really dream about that at this point. We can dream about it, but it's really beyond our reach. Mars is sort of there, right? Moon definitely is, I think, for the next step. So I think better ways to travel and get around would be really nice.
I think we have evolved good technologies for dealing with the hostile environment of space, but we haven't generally begun to scale those in commercial ways. So what do I mean by that? If you look at the way large bespoke satellites have been built historically, they're largely designed over a long period of time with a lot of specialized component technology and designed for 30 years of resilient, fault-tolerant life on orbit. And we're moving to a world where we want to be able to produce a lot of smaller satellite capability, and the component supply chain is not there. And it's not there to enable energy management, to enable good standardized network communications. It's not there to enable just a resilient on-orbit control system. If you were to look at the history of the small sat constellations that have been deployed so far, if you look at what Planet has done and what Spire has done and others, if you look at their first generation spacecraft, you would see that they made, as a company, about 20% of the spacecraft, and they outsourced the rest of it. They bought it from component suppliers. And I promise you that if you looked at the success rates on those early spacecraft, you would be pretty discouraged. Because there was a lot of component failure from really weak vendors. Fast forward to today, Spire has 50 satellites on orbit, Planet has over 100, and those companies make 80% of the spacecraft. They have had to develop all of that component capability in-house, and they've come up a learning curve in doing it because there is no supply chain available to deliver good standardized capabilities for these platforms.
I think one thing that I can add is almost a second that the component play is going to be critical. And the idea is that all of these big players that we're naming and you guys probably all want to work for or bring technology to, they're going to verticalize for exactly that reason. And so there's a huge gap in the market right now on the material side, on beam steering, on optics, on propulsion, and these are the areas that even as a strategic, we're examining very carefully because that's going to be the game changer here. And one of the reasons, I think I have a better answer to, is it just idea and execution? No, it's what is that underlaying, fundamental technology that helps create or actually realize that idea. And if that doesn't exist, then you have to go back to the drawing board and say, well, I can't get to the moon and do all these things that I want to do because the first thing that I have to worry about is whether I can efficiently launch the payload and that payload is protectable in space and won't, sort of fall apart while it's in orbit because it's very hard to recover or sort of modify or adjust that kind of an asset once it's launched.
Good. And when you talk about space startups, quite often we talk about space companies that will be addressing challenges related to space exploration. Do you guys think that it's possible to create sustainable space startups specifically for those purposes, or somehow the most promising ones would have some kind of connection to the economy here on Earth?
What was the last part?
If the companies, the startups, they have to necessarily to be sustainable, to be connected to the economy here on Earth, or they can focus solely on space exploration?
Well, as far as I can tell, the only people who are paying are here on Earth. So the dollars have to flow from some customer that is based here. That may be a government, it may be a financial market, et cetera. Look, you know, we as an industry and as a community today are benefiting from the largesse of government research dollars and development that have advanced our space program over the last 50 years. But we're also at a moment where the question is being called earlier and earlier on the commercial viability of these businesses. And I think that you will see in 2018 you'll see a divergence. You'll see a bunch of the promising, innovative space companies we've talked about accelerating and demonstrating their commercial viability as business models, scaling their revenues to the tens and hundreds of millions. And you will see others that fall away either because of lack of funding, dollars dry up in the sector, or maybe something technically doesn't work. Although I'll tell you, of the reasons for failure, technical failure is the one we worry about the least in our world.